All right, so now we're going to be looking at exterior intersections. So when you have exterior intersections, these are going to be with secants and tangents that are obviously going to be on the outside of the circle. Then the measure of the angle formed is going to be equal to half the difference of the intercepted arc. So let's break this down. If we have two secants, and remember a secant goes through it twice, so you can see that here with B, C, D, and E, it's going through the circle twice. So when that's the case, angle A, right there, that is going to be equal to 1/2 times the measure of arc CE, which is this right here, minus the measure of arc BD, which is this one right here. Now, if you have a secant and a tangent, then when that happens, because the tangent is going to hit it once, secant hits it twice. So in this case, angle A right here, that is going to be 1/2 times the measure of arc BD minus the measure of arc BC. So right here is BD, and right here is BC. And notice I'm doing the bigger one minus the smaller one. Same thing over here, CE minus BD. So now if you have two tangents, so this is when the line is going to hit the circle once, both times. So angle A right here, that is going to be 1/2 times the measure of arc BDC, so this big arc right here, minus the measure of arc BC, which is going to be this little one. So once again, bigger minus the smaller. So now let's look at number 10 here. We are trying to find the measure of angle KLM, which is right here. So once again, you're going to do 1/2 times the bigger arc, which is right here, 140, minus the smaller arc, which is going to be 66. So when you're going to do that, you're going to have 1/2 times 74, and then your final answer is going to be 37 degrees. Moving on to number 11, we're looking for angle ABC. So we need to know what this big arc is going to be. So what you're going to do is remember, circles add up to 360, because we know that that's going to be 88 and that's 62. So just do 360 minus 150, since that is 88 plus 62, and that number is going to be 210. So up here, the big arc is 210. So now, let me change the color. Make this blue. For the measure of angle ABC, you're going to have 1/2 times 210 minus 62. Because remember, the big arc minus the little arc. So 1/2 is going to be times 148. And 148 times 2, that is going to be 74 degrees. Final answer. Moving on to number 12, we want to find angle PQR here. And now we're actually looking at two tangents. This one was when you had a tangent and a secant. This one had two secants. So now we're looking at one with two tangents. And notice they only gave us the measure, let's do better than that. They only gave us the measure of this big arc right here. I need to know what the measure of this arc is going to be before I can even find the angle. So to find the measure of that green arc, once again, you're going to have to do 360 minus the arcs you do have, which is 313. So 360 minus 313, that is going to get you 47. So that little green arc right there is going to be 47. So now we can find our angle. So 1/2 times 313 minus 47. You're going to get 1/2 times 266. And then your final answer will be 133 degrees. There we go. Number 13, finding the measure of angle BCD. So right there. So once again, I'm missing some of my pieces here because we have the 67 right here, which we're going to end up using, but I need to know what that little arc is going to be. So I can find that by finding all my other ones. So one thing to make note of is this secant line that's cutting through right here. It's actually the diameter since it's going through the center of the circle. So then we can safely assume that this big arc right here is actually going to be 180 since it's cutting through that diameter. So now we can add this, and this together and subtract it from 360. So we're going to have 360 minus 341 when you add all three of the circled numbers together. And then when you subtract those from each other, you're going to get 19. So right here in the pink, that is 19. So now let's find our angle here. So 1/2 times 67 minus 19. Remember, you always want the bigger number first, or the bigger arc first. So we're going to get 1/2 times 48, and then that's going to end up being 24 degrees. So now for number 14, I need to find the measure of the arc, and in this case, SW, which is the bigger of the intercepted arcs. So the way we're going to do this is we're actually going to make an equation here, because they give us the angle, and we also have the measure of the smaller arc. So we're going to set it up as 40 equals 1/2 times, and since it's the bigger arc, I'm going to go ahead and call it x, since that's what we're trying to find. And it's going to be x minus 75. Okay? Alright, so now we need to solve for x. So I want to get rid of the fraction, so I'm going to multiply the whole thing by 2. So when you multiply this side by 2, the fraction's going to go away. And then 40 times 2, that is going to be 80. And now it's going to be equal to x minus 75. So now add 75 to both sides, and x is going to be equal to 155 degrees. In fact, let me circle it in pink, since it's the pink arc. Degrees. So now, number 15 here, we're looking at the measure of arc QU, which is, once again, our bigger arc. So we're actually going to do the exact same thing, since we have the angle and we have the smaller arc. And once again, I'm going to go ahead and just call that x. So 35 equals 1/2 times x minus 46. And once again, I need to get rid of this fraction right here, so I'm going to go ahead and multiply everything by 2. So now 2 times 1/2, that's going to go away. 2 times 35 is going to give me 70. And then now that is going to be equal to x minus 46. Add 46 to both sides, and then you're going to get x equals 116 degrees. That's the measure of the larger arc. Now let's find the measure of MK, which is actually the smaller arc this time. So, still going to be the same process actually, only now we're looking for the smaller one. So, we have our angle here of 56. So 56 is going to be equal to 1/2 times, and now we're actually going to put the 160 first. Because remember, you always put the bigger arc first. So, let's try again. 160 minus x. So, we still got to get rid of that fraction. So multiply by 2. That's going to go away. 56 times 2 is 112. That's going to be equal to 160 minus x. Subtract the 160 from both sides, and we're still going to have a negative x. And now we're going to get negative 48. But the x is not by itself. I need to divide by that negative 1. So x is going to be equal to 48 degrees. That's going to be the measure of arc MK. Last but not least, we need to find EF, which is actually this arc over here. It's not even related to the ones that we've been trying to solve. So the way that we have to tackle this one is we're still going to have to set up the same equation that we've been using the whole time to find this arc, and then once we have that blue arc right there, that'll help us find the pink one. So for now, the blue arc is going to be x. We need to solve for that first. So we have our angle, and we also have the larger arc. So let's set up our equation. So 77 is equal to 1/2 times, and then the bigger arc first, 191 minus x. Solve for x. But you want to get rid of that 1/2. 2 times 1/2, it goes away. 2 times 77 is 154 equals 191 minus x. Subtract 191 from both sides, and you have negative x, and that's going to be equal to 37. And then divide by -1, and x will be equal to positive 37. But we're not done, because this right here is the measure of this. But I need to find the measure. Oops, let's try again. There we go. I need to find the measure of this pink arc right here. So this is going to be 37. We're just going to do 360 minus 191 and 37. So we're going to have 360 minus 228, since that's 191 and 37 added together. And then when you do the math for that, you're going to get 132 degrees. That is going to be the measure of arc EF. And we're done.